Hi everyone, we need to work on a second trick for solving quadratics or things that have that kind of quadratic structure. And this one is going to be using complete the square, which I know is tricky on expressions, so I'll start by going back through that. It's a similar trick, so if you're starting to get it with expressions, that'll give you a good leg up on getting this down. It's going to look a little bit different when we're doing it to an equation, but it's very similar steps, so just difference in the fact that we can use some properties of equality to help with what we're trying to do. So just to remind you, we should know how to complete the square on an expression. And I've written out our steps because those steps we will follow. It's the same steps. It just looks a little different when you have an equal sign to help you isolate things. So our first step is to isolate x squared and x, which really we kind of just do mentally. This very first step, we want to split those off and say, I'm just working on that, trying to make a square out of it. The second thing, and usually I do these two both at once when we're working on an expression, is to make sure that the leading coefficient is 1. The leading coefficient is the one hooked to the biggest power of your variable. So I need to do that in this case by factoring out a 3. Plus, there we go. Okay, and we're just ignoring that 5. That's the whole isolate x squared and x part. Now we finally get to complete the square. And remember, the trick for complete the square is you take that number in front of x, you cut it in half, and you square it. So we're going to take this number, and we're going to divide it by 2, and then square it, which is going to give us 2 squared. So the magic number in this case is 4. Whatever you do, because this is an expression, whatever you do, you have to undo, right? So we can multiply by 1 when we're working with an expression, or we can add 0, or we can just simplify pieces. So in this case, we want to add 0. We have to be very careful because we so far have added not just 4, but actually 12, 3 times 4. So to make it 0, we have to also subtract 12. And the last thing we want to do, so that was step 3, complete the square. We made it a perfect square. The last thing we want to do is factor the perfect square. So that factors into x plus 2 times x plus 2. And you should always see this b over 2 number showing up in that spot. And then we have a minus 7. Okay, so that's how you complete the square on an expression. Now we want to do it to equations. So we're actually going to follow those same steps. It's just going to look a little different because we're going to take advantage of the equal sign. So the first thing we want to do is isolate the x squared in the x term. So actually I take it back. The first thing I want to do is distribute through the parentheses. You'll notice that some of these examples, they're maybe not exactly the same. I think one is exactly the same, but similar to the examples we had in the last section because they're quadratic again. So first thing I'm going to do is get rid of the parentheses. Okay, so we want to isolate the x squared in the x term, and with an equation, this is exactly how I do it. Instead of leaving the 5 with the x squared in the x term, I move the 5 to the other side. I luck out here because it's already been done for me. The second thing I'm supposed to do is make sure my leading coefficient is 1, and I actually luck out. This one's an easy one that I'm trying to start us with. The leading coefficient is already 1, so I don't have to do anything. What I would do if there was a number there, though, is not just factor it out, but actually fully divide it out, divide both sides by that. Since I now have an equal sign, I have more tricks that I can use than just adding 0 and multiplying by 1. So now it's the complete the square step, finally. Finally, we haven't really done anything else. You take your b, you cut it in half, you square it, and we're going to say that gives us x squared minus 3x plus 9/4. And now, instead of having to also subtract the 9/4, we just add it to the other side as well. So now we're maintaining balance by keeping the two sides the same instead of just by adding and subtracting to make sure we didn't actually change the value. So let's see, what does this give us? This is 20 over 4. So I have 29 over 4, and I do try and do a little simplification as I go so it's easier at the end. And I'm on what was my step 4, which is factor the perfect square. So remember, I guess in some ways I gave us kind of a tricky one because this is a fraction. This number right here should always come into play. We want to split the factors are supposed to be identical. So when we do that inside outside, they have to be the exact same number. which is always going to be half of whatever this is. So minus 1.5 squared. And I would say if you're continuing to just not really feel like you get what's happening there, multiply it out, x minus 3 halves times x minus 3 halves. If you do that enough, you'll start to see why this works, why we need half of that number, and why this is the square of that number. That's my best advice. I can say different things, but I think it won't help unless you just kind of play around with multiplying those out and see why those match up. So we're now done with the steps we would have done for expressions. Again, they look a little bit different because we have the equal sign, so we can move some of the mess to the other side of the equal sign. But what I want you to notice is the whole trouble with quadratic equations is to solve an equation, we need to get down to a single x. And when you have an x squared term and an x term, there's no way to combine them. They're not like terms, and it makes it really challenging to do that until we learn some new tricks. So one of our tricks is if the equation is factorable, set it equal to 0, factor it, and you can split it into simpler equations. That is always the easiest method. That is always the best one. The problem is not everything is factorable. And I think that what we'll find is this one. Yep, I'm looking carefully now. This one would not have been factorable. If we subtracted that 5 to the other side, we would have gotten stuck. So I would always, given a choice, try factoring first. Your homework's going to ask you to complete the square so that you can get some practice. But one of our goals will be to, at the end of all this, once we've got our 3 different methods under our belt, look at these and try and be smart about choosing which one we want to use. Okay, so now that I'm down to a single x on one side of my variable, this should be a lot easier to solve. And that's what complete the square does for you. It gets you from an x squared and an x to a single x, and that's why it's powerful in multiple different situations. Even though it seems really tricky and tedious at first, if you can get this trick down, it'll start to feel like a really quick, easy way to get some good information. So I need to reverse order of operations. So I'm seeing that the first thing done is I subtract 3 halves, and the second thing done is I square, which means I'm only going to have to get rid of 2 things. I'm going to get rid of the square root. Remember that to get rid of a square, let me try that again. I need to get rid of the square first. To get rid of a square, you need to use a square root. And whenever you do that, introduce a square root, you need to include a plus or minus. So the question is, what do I square to get 29 over fourths? And the answer is there's 2 things, a positive thing and a negative thing. I did do a step in here, so let me just show it in case anyone doesn't like it. Really, I get the root of 29 over 4, which is the same as root 29 over root 4, which is where that 2 is coming from. So if you've got perfect squares, take advantage, take the square roots. Okay, so the only thing I have left to do is get rid of that 3 halves, so I'm going to add that to both sides. Since it doesn't have the root, I can't combine it with the root 29. So you can write it, it doesn't matter if it's before or after this, we're adding it on. The reason I'm putting it before is because in the next section, we'll be using the quadratic formula, and the answers from that look like this. So I don't really care if you add those 2 fractions together, but I just want you kind of used to seeing these messy answers. So that's the solution. I got 2 answers, which happens a lot. We're used to that. You could also get none. You could also get 1, but 2 we see a lot of. So that's how you use complete the square to help you solve an equation. It helps you get down from 2 of your variable with different powers to just 1 of your variable, which makes it easier to solve. Okay, so let's try again. So this one is set up in that sort of standard form, get it equal to 0. So we could even try and factor it. Actually, I don't want to. We're practicing complete the square, but you can always try, right? So make sure you practice complete the square. In general, the idea would be that you look at an equation and try and choose the best method. So if it's factorable, I wouldn't actually use complete the square if I was not intentionally practicing it. So first thing is to isolate our r squared and r terms. To do that with an equation, you're going to move that constant, that minus 14, to the other side. So I'm adding 14 to both sides. Your next step is to divide, is to make sure the leading coefficient is 1. Let me say it the way I said it earlier. And with an equation, instead of just factoring that 7 out, you can actually divide it out completely. Just make sure you divide everything. You don't get to pick and choose. So 7r squared over 7 is just r squared. Negative 14r over 7 is negative 2r. And 14 over 7 is 2. So next I get to complete the square. So I'm going to take this number, I'm going to cut it in half, I'm going to square it, which is negative 1 squared, which is 1. So I'm adding, I'll go ahead and just sneak it in here, 1. And since I have this equal sign, I don't have to add and subtract 1, I just add it to both sides to keep my balance. So on the right-hand side, I now have 3. On the left-hand side, I should be able to factor into a perfect square. And in this case, the perfect square is r minus 1 times r minus 1. So again, I know that complete the square seems challenging, but it's just a couple of steps. So if you can get it memorized and get comfortable with it, you can quickly, in a lot of cases, rewrite your equation in a way that makes it a lot easier to solve. We'll use this again for some graphing things. It gives you really valuable information when you're trying to graph things. Okay, so r minus 1 squared equals 3. I think I've just got a two-step going on here again. I'm subtracting 1, and then I'm squaring. So the first thing I'm going to do is get rid of the square by square rooting, plus or minus root 3. And the second thing I'm going to do is add 1 to both sides. So it's totally fine to say plus or minus root 3 plus 1. That's valid. You'll see me a lot of times favor this way. And it's just like I said in the last one, the only reason I'm favoring that is because when we use quadratic formulas, we're going to get answers that look like this. So it's kind of nice to see that your answers really look the same either way. Really similar stuff that we get out of those two methods. Okay, and as always, like checking is good, but these are quadratic, so you're not going to get extraneous solutions. So I would say unless you have a calculator, it's harder to check these than just to rework the problem real quick to see if you can catch any mistakes that you made. So in terms of mastery quizzes, I would not want to plug 1 plus root 3 in for r and try and sort that out. It's doable, but it's messier than the actual solving was. So you get a little bit of a funny thing that happens with some of the messy solves. Okay, let's see what else happens. Okay, and I think this one might be directly off your factoring, which I wanted to do on purpose. Make sure we do one that was factorable because the factorable ones should have nice answers, no square roots in the answers, and I want you to see that when we complete the square that'll happen as well. So once again, I don't really like this like partial factored nonsense, so I'm going to multiply through 6b squared minus 13b equals negative 6. And I do kind of like that my first step is really done for me, where I isolate the b squared and the b. So I can jump right to my second step, which is before I complete the square, I have to make sure there's a 1 in front of the b squared. So I divide out that 6. Whatever you do to the left, make sure you do it to the right. And I get b squared minus 13 over 6b, that looks horrible, equals negative 1. So that ugly thing, I'm going to have to do my usual trick. Ooh, I don't really like my use of b, because I usually call this b. So I take this, and I cut it in half. Remember that dividing something by 2, cutting it in half is the same as multiplying by 1/2, right? So I'm going to get negative 13 over 6 times 1 over 2, which is negative 13 over 12. And then I have to square it, which gives me 169 over 144. Yeah, see that 13 squared, usually I don't think we run into anything higher than that, but up through 13 squared is good to probably just have memorized because that one sneaks in sometimes. Okay, so I'm going to add 169 over 144 to both sides. So note this is a negative 144 over 144. So I am going to go ahead and simplify that, maybe 144, 54, 64. Ooh, it's actually nice. Okay, so it really is going to work out. This was the factorable one. 169 minus 144 is 25. And the reason I'm excited is because the top and the bottom of that fraction are both perfect squares. So we'll be able to square root it nicely. So this gets a little tricky. We're trying to factor and we're trying to make this perfect square. And when the numbers get really ugly, it can be hard for people to figure out what goes in this spot. So that's where I would remind you just that this number in the parentheses, half of this number is always what goes in that spot. So this is where the 13/12ths are going to show up, so that when you FOIL it out, you get negative 13/12ths b minus 13/12ths b, which is negative 26/12ths b. And negative 26/12ths is the same as negative 13/16. So it's messy, it's ugly. Me saying that probably didn't help. It still sounds terrible. But it's half of that middle number that goes in the parentheses when you factor. Okay, so two-step again, I need to get rid of the squaring and then the subtraction. So we're going to square root both sides, and this is where this one is a little bit different. Square rooting both sides still leaves me with a plus or minus, but I can actually do the work and say that's plus or minus 5/12ths. And then I need to add 13/12ths to both sides, plus or minus 5/12ths. Oh my goodness, 5/12ths. There we go. And this is the big warning I wanted to give you. If there was a square root in that answer, I would say, I don't have like terms, I'm done, good answer. There isn't. I actually do have like terms, so we actually need to split this up. This is really giving us two answers, right? I never want you to forget that. So this is saying one of my answers is 13/12ths plus 5/12ths, and one of my answers is 13/12ths minus 5/12ths. And you don't have to write this out the way I do. I'm having a really hard time getting myself to write 12ths apparently. But it's kind of a nice little way to organize it for yourself. So one is the plus and one is the minus, and it doesn't matter which is which. You could switch the top and the bottom is fine. So I get 18/12 for the plus. I can divide 6 out of that, and I get 3/2, 1 1/2. And then 8/12 for the bottom. 12. Okay. What can I take out of that? 4? Yep, 2/3. Hey, I kind of like it. So these are our answers. 3/2 or 2/3. Okay, so one more. So again, the big deal with that one is just when you get that plus or minus, it doesn't mean you can quit necessarily. If you don't have square roots, you're going to have to keep going. So last but not least on these, I think I remember what's special about this one. Let's go ahead and multiply it out, because for complete the square, we don't want any sort of factored anything to start off with. So I have a 2k squared minus 4k plus 3k, which is just minus k, and then minus 6 equals negative 15. Okay, so first thing, I want to isolate the k squared and the k. So I'm adding 6 to both sides, which is going to give me negative 9. Then I need to get 1 in front of the k squared, so I have to divide by 2. K squared minus 1/2 k. Remember, k divided by 2 is the same as 1/2 k. Dividing is always the same as multiplied by the reciprocal. We say that for fractions, but it's true for anything. Dividing is the same as multiplying by the reciprocal. Equals negative 9/2. Okay. If nothing else, this is at least another good fractions example, because those are always hard for people. So I'm supposed to take negative 1/2, and I'm supposed to cut it in half, divide by 2, which is the same as multiplying by 1/2, and then square it. So I get negative 1/4 squared, which is 1/16. Okay, so let's see. We need to multiply top and bottom by 8, which is negative 72/16. So I'm going to have negative 71/16, that's hideous, is equal to, and here's the factor step that gets tricky when there's fractions for people, I know. What I want is 2 of the same thing that add up to negative 1/2, so that would have to be negative 1/4 plus negative 1/4. So if I multiply negative 1/4 by negative 1/4, I get 1/16. And if I add negative 1/4 to negative 1/4, I get negative 2/4, which is negative 1/2. Okay, so complete the square. Now I need to solve. So first I'm going to go ahead and take the square root of both sides. Okay, whoa. I don't know how I just got an extra line there. K minus 1/4 is equal to plus or minus the square root of negative 71 over 16. Now you could certainly split that up and say, oh, the square root of 16 is 4, but I don't even care because there's something much bigger going on here. Oh, excuse my yawn. I am ending up with the square root of a negative number, which is not a real number. So I mentioned in the factoring section that quadratics absolutely can have no solutions, and here we're finally getting to see how that would play out. I was trying to solve this equation, and what I got down to is just that I'm not even getting an answer. There is no real answer to this. So it's not that I got a good answer and I threw it away. It's that I couldn't even get a good answer. So I'm just going to say this has no solution. Okay, so watch for that. You will see that happening in this section. We did this with quadratics, and I don't know that I'm going to have you do much in your homework, but I just want to mention that if it works on quadratics, then it would work on a rational or a radical equation that turned into a quadratic. So anytime you hit a quadratic equation, you now have two options. One is complete the square and one is factoring. Given a choice, try for factoring. It is easier. But I also hope that you find as you practice quadratic formula and you remember which steps to do, that it's actually a pretty slick trick. It doesn't really take that much work. I find people think that it's this really hard thing, but I think it's just at first hard to remember. So as you keep doing it, it should get really quick. It's really just a couple of steps to rewrite this thing. So thanks for watching.